my name is Kat, and I'm going to be doing a tutorial on data analysis and stuff, but how to be doing this on Mathmatica, so graphing stuff, also Mathmatica. So kind of heads up, Mathmatica is a all syntax based kind of program. It can go from very easy things to like 3 plus 2 to very, very complex stuff, but I'm fairly new to this. I learned this a couple months ago, or maybe like more than a couple than at this point, several months ago, like 4 months ago, and I'm starting to get the hang of it, so it doesn't take like too much of your time, and I started learning it during the semester, so I really didn't invest all that much time into it, and I started learning, so it's not like too big of a deal. I'm no expert or anything, so you'll probably see me searching around for stuff as well. It happens. But because it is so syntax based, just one of my biggest tips is don't be afraid to Google stuff. So yeah, but let's kind of get started. So the 3 sections that I'm going to be talking about or showing examples on is histogram, how to do a histogram, how to do a list plot, and how to do a best fit graph. So yeah, so I'm going to go into my Windows bar here because Windows is the best, and I'm going to be just typing in Mathmatica. So it pops up pretty fast. So you get this kind of thing, and I'm just going to do a new document. I'm going to save it from the start just so I don't forget. Control S, the same thing. I already have a folder, but if you don't already, which you probably don't, make a folder of everything that you kind of want. So I'm putting it in my data analysis because that's kind of what this tutorial is. So since I already have a brass properties, it was kind of my rough draft of doing this again just to make sure I knew what to do. I'll name this brass properties round 2. Yeah. So there's my notebook all ready to go. What you should do here is also, so this was for our class, our field session, we had brass properties in an Excel sheet, so that's kind of what this is. So I also downloaded that in the same folder just to keep things all nice and stuff. I'm gonna just open this up full screen. So the first thing that I'm gonna do is set a directory. That's really important for when you start needing to import stuff, which is what I'm gonna need to do because of back to the brass properties from all of the Excel stuff. So set directory, and then this, and close it. Oh, and then open, close, close. And then to push enter in this, it's pretty special. You do shift enter, and then it'll run it. Yeah, so this kind of tells you where we are right here. This is where the notebook has saved. That's basically what it is. And if you want, for syntax wise, since I ran it already and you don't want to see it anymore, you can put a semicolon, run it again, and you won't see it, but you have to run it first. I learned that the first time. You have to run it first, otherwise you can't import stuff. So now I'm going to go to formatting because I think it's great. So I'm going to do Alt-6, which is kind of like a title, and I'm going to name this import. I'm also going to be attaching to this video kind of the print, like a PDF version of this, so if you're a very visual person like me, you can also see it and you don't have to like watch this video. So if you click underneath the import, then you can start. Yeah, also for heads up, I probably should have said this before, but for a capital word, that means a function, and if you use these brackets, that means it's a function, what you want it to do. This is meaning, and you type something in, blah blah, like that, that means it's within a data set. This, like something like this, that means a list. And then, what I would like doing a lot is commenting, so you can just kind of type whatever you want, and it's not gonna have an output. So I like that, it keeps it nice. And then if you want to do ranges with lots of stuff, you do semicolons because that means through. So pretty easy. And if you ever have any questions with anything, F1, that button like finds everything and gives more information on whatever you're trying to type. So that's pretty good. Okay, so now for the actual importing, I'm gonna go through data equals import. bracket. For importing, it's kind of important that you have the same name. So what you could do is just copy the, like, retype out the whole name. What I like to do is copy. I would do Control C, but just to kind of show what I'm doing. And then Control V right here. Yes, you want to do the string. So because we already have this set directory and you ran it, you need none of this part. You can delete that. Oh, and that. And you can delete this one. Oh, and it had put another one. So there you go. And if you wanted to see all the data, you can run it. And then that's all of the data in a very not pretty form, but there it is. But I'm gonna semicolon it because I don't want to see that. So for the next line, I'm just gonna show you guys what the very first row is on here. It's the same thing up here as it is right here. So I like that, being able to see what I'm actually looking at. So that's how you import stuff. Pretty simple and straightforward. I like that a lot. So I'm gonna do another Alt-6 to give another title. And if you ever forget that, you can go up to Format, Style, and figure out what here you like. I like the subsection because it's just small enough where, like, it's not taking up the whole page, but big enough that it's like different from here. So yeah, it's up to you guys. So Alt-6, and I'm gonna show you guys how to do the histogram. So what this data was for is to show a brass tensile stress test, and we had to measure all of these things 5 times, and then do the thickness, and then see, these are the hardness tests right here, and just kind of show, for the histogram, I'm gonna just stick with the width, and the same histogram process can be done for the thickness, but I'm not gonna do it again twice to save time. So histogram, I'm gonna name this, so what I'm doing right now is naming the histogram. So I'm gonna name it rows, but then only column 11. That's what that means. I always get those two a little confused. 15 is just kind of how I like to spread it out. And then so I'm gonna do an arrow, which is you do the minus button and then you do that caret and then you push space. So pretty easy. Capitals and lower cases, it's very case sensitive, so keep in mind that. So what I'm gonna do now is, so the thickness was in micrometers, so I'm gonna push the escape button and you're gonna get that weird thing, and then M, and then escape, and then there it is. So right now, a lot of it is just titling the axes. So this is what an arrow looks like. And what's nice is it kind of tells you what, okay, so now I'm gonna enter it, and I'm actually gonna, okay. So that's kind of what it all looks like. Right here, this is the pixels. This is the, oh, I know why this is indented. That's part of the function. Okay, so font size of the labels. I like it in Times New Roman, black, bold. Frame, true, so that means that the axes are going to be lined up here rather than up here. If you like that, go for it. I like it over here. Chemistry kind of kicked that into me, so I like it that way. Yeah, right here, and right here, these are all the titles that are like specifically there. And then this you can just kind of mess with the sizes to see if you like it or not. But yeah, and then the 15 right here, I think I've said before, that is how many bins that it divides into. Awesome, so the next thing I wanted to do was list plot. This is going to be for the data that involves more the temperature, like time, like hardness, that kind of stuff. A little bit more difficult that one would think to graph. So yeah, so I'm gonna start off with the Alt7 again, Alt6, I'm sorry. So calling this list plot. Okay, so I'm just gonna show you guys what the data looks like in a grid after we decide what is kind of important and stuff. So I'm calling like this variable or this data, I'm gonna call it hardness. Oops, I spelled that wrong. Hardness. And then we're equaling that, and so you don't have to do this, like calling it that, but you should name each little thing, so then if you want to grid something, it's much easier once you have like a name to whatever you're looking at. So, data. So these are all the rows it's going to be looking at. I could not find a way to do this more efficiently besides writing down 18 through 25. So I tried the through and it wasn't working for me. Maybe you'll have better luck with it, but yeah, so let's see. So I personally don't want to see all this data, but this is what it looks like. That kind of looks like a mess right now. So this person right here, which is what you're going to see in the grid, did not put in their data, so that's why there are some extra commas. That this person at 600 didn't do it. Someone put as received, so they didn't know their temperature that they got their brass from. But if you see blank spaces, that's why. So I'm going to semicolon that, and yeah. So to show a grid, it's pretty easy. You just do grid and then the variable name, which we call hardness, which is why it pops up here. Oops, it disappeared, but that's why it pops up there. I'm gonna push enter, close it. Now I'm gonna enter it, and it looks so much cleaner than what it did before. So now I'm gonna show you guys how to do if you want to see like a specific row and column, this is how you do it. You do hardness, how nice it pops up. Mathmatica is strong and powerful and knows what's up. So, and then I like how it tracks that as well. So yeah, on the input, the very first thing that you see is temperature for that position, and then href1 for this position. So so you can see it popped up here and here, but it's not quite as simple as that since we had a huge gap of data in between there, but that's kind of what you can do if you want to see that. Another cool way to, just another way to do this is, I'm gonna put in another one of hardness, because now we'll be getting actual data. So this is kind of the way list plots work, is that they'll go through every single like column and work that way and see this is the X point, this is the Y point, and graph it. So that's one really cool way, but one of the best things I've seen is a good explanation is this, if I could spell it, manipulate the hardness at A. And then since what we're looking at, this position, this part doesn't move, that again is not going to change, but this A part will. So this part is going to change. So yeah, what I really like about this manipulate function, it's a really good way to explain what's happening. So if you change it, okay, so this 500 didn't put anything, but as you keep increasing, so the 400, here's the x, y, 400 x, y, and it'll just keep changing. And what's nice is you can go through and actively change it. So it's gonna go through each of these points. Oh geez. Who put this as received? Where is that? Dear God. Oh, there they are. Great. Not helpful. But yeah, so you can see how the way it's literally going to be doing that, and that's how it's going to be graphing the list. So, since I am a scrub and I could not figure out how to do the degree sign without doing this, I have to put in as a function, and that's my degree sign that I can use for the next part. So I'm going to be calling this list plot, not very creative, href1, and then equals, and this is the actual function now, list plot. And yes, you can graph in 3D, which is special. So yep, here we are. When you push enter, you get to see it. Yeah, so this is just the same kind of outline as it was for the other one, so I'm not going to go into explanation about that one, but yeah, so the next one I'm going to do is a best fit line. This is actually a really bad data to do a best fit line for, but I think it's really important to be able to do, so we'll do this in theory. But so we're gonna name this plot, and for the function, capitalize plot. So heads up, this is not gonna fit like at all. I didn't know what kind of shape that this would be. Maybe parabola, maybe like, I was thinking the inverse or like the opposite of a log, but that wasn't right either, so not 100% sure what it is, but you can figure it out with a little exploration. And so you could do shift this to represent squared, but I'm a very visual person, so I do control caret and do 2 because it looks much better. Just some hacks, I guess. Oops. I'm going to close the whole thing, run it. So this is kind of how if you want to plot a normal thing, like a normal graph, that's how you would do it. So to make this kind of special, to make it like a best fit line, what you do is graph this plot on top of this plot. So we named this list plot href1, and we named this one just a normal plot. So to show them together, like the graphs together, you just do show, which would make sense, function list plot, which it comes up already, comma, and then plot, which that comes up already. Close it, shift enter, and yeah, so that's kind of how you graph on top of each other. Clearly it's a best fit line, but if you play around with it a little bit more, you can change the size of it, and I think that's a pretty good arc length, I guess, so you could change that. But yeah, so this leads me to the almost the very end of the video, but this is one of my favorite things to play around with. So I'm Alt-6ing again, and this is which I didn't mention at the beginning, the 3D plot. I kind of wanted to leave it as a surprise, but this is something that I personally did not do for this data, so what I'm just graphing is just like a graph, but it's a good important skill to have if you want to really know stuff and impress all of your friends and stuff, because a lot of people who aren't or who are in the MME department seem to be kind of surprised when one knows how to use Mathmatica. It's more of a physics, maybe math kind of thing, so it's a lot of fun. I like programming, but so that's why I really enjoyed this, and that's why I picked it. But so right now I'm just kind of graphing just like a sine curve and giving the x right here, I'm giving it parameters, and I'm gonna type in the y parameters, so it's not gonna be some crazy graph. And then I have to close it up because it tells you right there to close it. So I'm closing, and yeah, that's it. So I think this is really fun because it's interactive, so you can actually look around it, and if you're blind like me and that's not big enough for you, you can click on the picture itself, like a normal picture, one actually not complex thing, and you can make it as big or as small as you want it. So if you want to be able to see stuff, that's kind of what it looks like. I don't know, I think it's a lot of fun, and if you want to get complicated, you could change the colors. I've made it like LGBT, like rainbow colored, which is a lot of fun. So I enjoy 3D plots a lot. They're a lot of fun to play with the colors, a little bit more so than the 2D, at least in my opinion. I like the 3Ds better. But last but not least, I'm gonna show you guys how to export. So if you need these pictures in a LaTeX document, or if you want it just to send to a prof or a friend, this is kind of how you do it. So for these ones, I personally don't like having output statements, just because what it will output is the exact same thing as what you're typing in. But for the export, it's pretty safe to do. So average thickness, and this is going to save within the file that we made earlier. So this is what I'm saying. So this is the name of the very first histogram we made, and I'm choosing this in PDF form, finishing off the quotes. So I'm doing a comma, and then you just type out what it's called in here. It should pop up. Close it with a bracket, and I'm semicolon it. So then I enter it, and then I'm doing another export. I'm just going to export all of these. I spelled export wrong. You can do JPEG. that's not really going to change anything. All you have to do is the name of what you're looking for in the form that you want, and then comma, and then what it's actually called in here. Okay, so now I'm gonna run it. Yeah. So I ran it, and so there, although there's no export statement, you can go back and check. And so here they are. We can see them right here. Yeah. So that's a good representation of how that works. So yeah, I hope you learned something on Mathmatica. Yeah, sorry for the speed ups and the mess ups, and yeah, but I hope you learned a lot, and I hope this was a good learning experience. So yeah, have a good one. Thanks.